Hello, this is Russell from the Tate Geological Museum in Casper, Wyoming, and today I'm going to talk to you about something called unit cells. You might not have heard of these before. We all know that minerals come in the form of crystals, and like everything in the world, crystals are made out of what? What are they made out of? Does anybody know? That's right, atoms. And atoms then are joined together in larger clusters, larger structures of multiple atoms called, anybody know this one? Molecules. Now with minerals, what often happens is that those molecules will get together in groups, usually of 8, and form what's called a unit cell. And different minerals have molecules with different shapes and properties, and they will join together in unit cells that have different shapes. You can see examples of those different shapes right behind me. Take pyrite, for example. Here, the molecules of pyrite are all joined together at right angles to one another, and they make a shape like a cube. But, as you can see from the other models in this display, other minerals will have molecules with different charges and properties and shapes, and they will make unit cells of different shapes from each other. Now, the reason this is important is because those unit cells are the building blocks of crystals, literally the building blocks. And a good way of thinking about how this affects crystal shape is to look at Legos. So here's a 2x2 peg Lego building block. So let's say that you've got a mineral that forms unit cells that are this shape. Well, that's only one unit cell, but as that crystal grows, other unit cells are going to attach to it, all around the edges and on the top and on the bottom. And then more are going to attach around the edges, and then more on the top and the bottom, and more, growing out from that central original unit cell in all directions, more or less at the same rate. And so eventually, you're going to end up with a shape like this. Here, let's get that last guy in there. So here, all of this is all made out of those little 2x2 units, at least in our model here, and it makes a particular shape. And as it gets larger and larger and larger, the blockiness is less and less evident. So by the time it's actually a full-size crystal that you can see with your unaided eye, the shape of those unit cells and the way that they fit together as the crystal grows has an effect on the shape of the finished mineral. So a unit cell shaped like that would make a crystal that's more or less like this in shape when it was at its full scale. But what if we took a unit cell of a different shape? Here's a 2x4 Lego block. So if we did the same thing again, put unit cells, the same shape, all around it and on top and on the bottom, and then another layer all around it and more on top and more on the bottom, building out in all directions, then we'd start to get a different shape, a shape looking like this. And when this then grew into a full-size crystal, it wouldn't look like this. You wouldn't have a point in the center here, for example, because since these unit cells are longer, they're going to form a row at one end, making an edge. So the finished mineral crystal for something like that would end up looking more like this. So when you look at the different kinds of crystals and see all those different shapes and you ask yourself, why is it that they're shaped like that? It all comes down to the unit cells.